welcome. Thank you all for being here. Can I just maybe ask you all to briefly introduce yourselves?
I'm Tim Abell. I've been a developer for 25 plus years commercially. I've been getting into Rust lately. It's a fascinating field, like as much from enthusiasm as for its properties. I'm coming at it more from I've done lots of other higher level languages, and I'm going to be bringing that perspective to this discussion.
Hi, my name's David Haig. I've been working commercially for about 21 years or so, mainly in banking and in sort of higher level languages like Java and C#. But I've recently, well, in the last 6 or so years, I've been using Rust quite a lot, focusing mainly on embedded stuff. Primarily, first of all, as sort of on the hobby end, and then recently started a company building a physical product in Rust. And I've also built a open source hearing aid recently, so that's me.
Hi, I'm Ethan. I work at a payments company called TrueLayer. I've got a lot less professional experience than my two friends here. I've been working professionally and been using Rust my entire career for 3 years. My interest in Rust started as a student, and yeah, Rust is all I've used professionally. I now think in Rust.
That is good to hear. Okay, so opening question, a little bit of a warm-up. Before we dive deeper, can each of you maybe explain briefly, or share one example illustrating why memory safety is such a critical topic in software today?
Sure. Before I dive into that, I just want a quick idea of where everyone's at on Rust in the room. Like, hands up if you've heard of Rust. Hands up if you've used Rust. Hands up if you've used Rust for more than a year. Hands up if you've used it commercially. Okay, cool. So we've got some understanding of what's going on. Okay.
You've lost your mic.
Short-lived. So in terms of memory safety, for me, I think probably the biggest thing to highlight is I've been on a few projects where they've been deciding on software languages, and because I come from languages like C# and Ruby, which are high level, languages like C and C++ just would not be considered at all to replace them as line of business applications, because they don't bring you can't do these memory unsafe things, you can't introduce these security vulnerabilities. I'll pass on because I don't want to take over the whole thing.
Yeah, so in my mind, memory safety is critical for the main thing is people think about is security. So Microsoft, there was a security conference a couple of years ago, and they famously, one of the Microsoft engineers famously said that of all the security vulnerabilities they had fixed that year, 70% of them were caused by memory safety issues. So when people think about memory safety, they kind of think about it from that perspective, but it's not just that perspective. And I'll give you an example of something from an embedded realm. So you think of like a physical machine that's running that would crash because of a memory bug, say an out of bounds access or something like that. And then a concrete example would be a hearing aid. So last year I worked on building a hearing aid, and most of the memory is taken up by the audio buffer. So that's the audio data that gets ultimately sent to your ear. Now, if you have a memory safety problem, you can overwrite that information, and you can cause hearing damage because you can write garbage, and it can those amplifiers are really strong, and you can cause damage. So that's an example of sort of memory safety actually going into the real world, so being a safe language. And that extends to automotive, to all sorts of things. So yeah, that's why it's important. Yeah.
Yeah, I won't add a huge amount to this point, but using Rust in comparison to other languages, like we talked, I think Tim mentioned briefly about like using Rust in comparison to other languages that are also memory safe. But I think Rust gives a bunch of advantages in being both memory safe and also giving you that low-level control at the same time. But I think we'll touch on that a bit more in some of the other questions, so I'll leave it for that.
Well, yeah, that's a very nice segue into the next thing I was going to ask, because obviously Rust, I think, surprisingly, already has kind of dominated the, okay, if you're thinking of a memory safe language, an awful lot of people kind of immediately think Rust now. But, you know, it is not the only choice for memory safety. So, I mean, maybe Tim, throwing this to you, sort of, some people might say, I don't need memory safety. Languages like C# or Java might already handle that. But how would you respond to that? How do you think that, you know, Rust, how is Rust different? How is our approach different here?
Yeah, I'll talk a bit about my personal journey into Rust, because memory safety wasn't really a factor for me considering it, because I'm coming from C#. I was not thinking, oh, I need some memory safety. What brought me into it was I was looking at the cloud cost and the performance. I was looking at building a SaaS app, and I was thinking, well, if I need to scale this up to significant volumes, if I run this on C# or Ruby, I'm going to get eaten by hosting costs before I get this thing off the ground. So I was looking around and I came across Rust, which has all of these high-level language features, has all of the safety, but also is super efficient on the server. And then having got into it, like I spent some time writing a command line app just to kind of find my feet in the language, and finding myself like really liking it. Like this might come across as a bit of a sales pitch as a talk, but like I genuinely just like I'm interested in technology. I love my programming. I love my languages, and I've really started to like it as a language, having used all sorts commercially, personally as a hobby. Like to have some specific examples, like in C#, in the commercial projects I work on, we're just plagued with things like a null reference exception with not enough information because someone assumed that something wasn't going to be null, and then that came out. And Rust just has really good ways of dealing with lots of things like that. But unlike Golang, which I spent some time working with, it's still a really nice high-level language. Like I don't feel constrained by it as a language. So there is definitely a lot on offer from Rust. I don't know if you two want to say anything on that.
I can add some stuff. Yeah, so the sort of the physical difference between this whole memory safety in Rust and a managed language. For starters, memory safety is generally classed as, you guys probably know this already, but for the people who don't, memory safety goes in the same group as managed languages. So meaning you can't do things, there's certain rules that you can't break or that you shouldn't break, otherwise you get this thing called undefined behavior. But the main way that languages have traditionally dealt with this is having a thing called a runtime. So in C# and Java, they'll have a garbage collector. In C++, you can get a semblance of memory safety using a pattern called RAII or something. Resource acquisition is initialization. It's not the same thing, but it's moving towards that. But it's also actually a runtime thing, even though it's less of a performance thing than a C#. However, the thing that sets Rust apart is that it's what they call zero cost. So it's all at the compile time. So all the stuff. So you can think of all the memory safety stuff as being all these rules that you have to follow as you're writing the code, and the compiler checks it all. And then when it's running, because it's already done that check, it doesn't have the overhead of having to check it when it's actually running, which has lots of benefits, like you're pretty certain it's not going to crash at runtime for these sorts of classes of problems. Yeah. And that's why it's considered much cheaper to, for hardware costs and all that sort of stuff, because it doesn't have this extra overhead.
So yeah, Ethan, this is, we're talking null references, sort of immutable by default. Can you add to that?
Yeah, so I think so, because Rust provides a really strong type system. So you can guarantee a lot at compile time, and like ensure a lot of things. I find it particularly interesting using the type system for higher level problems. Now, rather than just handling memory directly and ensuring you have memory safety, but you can do things like using the ownership model, which is how Rust manages memory safety. But you can use it to manage ownership over maybe high-level resources. Maybe you've got access to a file, and you need to be able to ensure that when you actually delete that resource or you close that file, there's nothing else that's going to be interacting with that file after you've closed it, and you can make use of Rust's ownership model to do that. And that becomes particularly helpful if you've got maybe if you've got some async code or you've got some code that's doing some parallelism. That becomes particularly helpful.
Thanks. Yeah. So going a bit further, talking about the garbage collector or lack of it. I don't know how many people here are really, really familiar with garbage collector versus non-garbage collectors. So maybe one of you can say a little bit more about that.
Yeah, sure. I'll speak a bit to that. So, like, to take a specific example, I wrote a project in Golang, which when I picked it up, I was viewing it as more of a low-level language than C# that I do for a lot of business clients. I kind of take for granted in C# that when I assign a variable or create an object from a class, that I don't have to worry about where that is in memory. I don't have to think about it at all. But something does, because at the end of the day, they're still von Neumann machines. They still have this architecture where there's CPUs and memory, and they have to allocate and keep track of what's in use and what's not, so that you don't run out of memory or have the wrong program using the wrong piece of memory. And there are quite a few different models for, like theoretical models, for making sure that the wrong thing doesn't use the wrong memory, that it's released back to the operating system when the program has finished with it. And one of these is generally known as garbage collection. And what you, even within garbage collection, there's some variation, which I won't go into too much, partly because I'm not an expert in it. You get this thing called freeze the world, mark and sweep. So during the course of a C# program, you've allocated a whole bunch of things. You're up to a gigabyte of memory because you've been dealing with all sorts of requests coming in from users or whatever it is you're dealing with. It will stop your program executing. It will check all of the memory that's in use and follow the tree and go in use, in use, in use, not using, not using, in use, in use. And then it will tell the operating system you can have all of that memory back, and then it will resume the program. And like we've been saying with what we call the borrow checker, which is a bit jargony, but basically that's the way of not needing to do that. So just at compile time, Rust knows when it can free back to the operating system reliably. In C++, you can do that, like you say, it's RIA, it's hard, isn't it? Yeah, resource initialization is acquisition. Is that right? RIA?
Resource acquisition is.
Let's not dwell on that. So, like, I have a friend who's been doing C++ for 15 years, and I would consider an expert. And like, it's one of the earliest things he said to me. It's like, the RAI model, this means that you don't make these mistakes. But whereas with Rust, you can take a new program and go, don't worry, you're not going to mess this up. Like, you have to have done C++ for 10 years to not make that mistake.
And it's opt-in.
Yeah. Does that kind of cover? I'll pass over and maybe you can fill in any gaps I've missed.
I think you've actually covered it all. Yeah.
Fine work, Tim. Thank you very much. I think maybe kind of moving on a little bit, Ethan, I think maybe get your thoughts on this. Thinking about the developer experience, what we're calling cognitive costs of using Rust. I mean, some people have argued that Rust's ownership rules introduce extra mental overhead for people that are using it. So how, in your experience, how do you think development teams are managing or even benefiting from those kind of roles? And maybe, further on, I've got a follow-up question, but take that first.
Yeah, so people generally expect Rust to be hard to learn, and it is. It's a fairly difficult language to pick up. But so I've at TrueLayer, we've onboarded a number of Rust engineers onto Rust teams, and we tend to see people can pick up Rust fairly fast. If you've got like maybe one or two seniors on the team, they're able to support them in that learning experience. But generally, I find that people learning Rust, even if they're on their own, they've not got that support. The learning curve is very long, but it's not that steep because there's a lot of guardrails helping you up along the way. The compiler is extremely helpful. It generally just tells you what you need to fix. And we have tools like Clippy that do linting, and they can teach you new Rust techniques when you make mistakes. And generally what you find is you can put a junior engineer on a project, and they can make some changes, and you can be fairly confident that if it compiles, they haven't broken something in a catastrophic way. But it will take them a while to get it to compile, but you can then have that confidence.
Things to add. Just to add a little bit to that, the tooling around Rust is what helps a lot. So the fact that there's one package manager that everyone uses, the fact that there's pretty much one language server, so there's one autocomplete thing that everyone uses, is a great thing. And that's just because I guess it's a new language and people are sick and tired of having different. There's one formatter as well. So when you Rust format, it lays out the code in a very specific way, and that's really important as well. It might not be everyone's cup of tea, but when you look at someone's code, everything looks the same, and that also helps with sort of this imposter syndrome that you have when you starting a new language, because you think, well, I'm not good enough to show other people my code, but if your code looks exactly the same as everyone else's because it's running through the same linters, so there's this thing called Clippy that you mentioned, if it's running through the same formatter and it's really hard to compile, so if it compiles, it's reached a certain bar, and that helps people to put their code up there, which is kind of why it's such a big open source sort of phenomenon, I think. Yeah, I think that
It's so funny when I first came to Rust and everyone was talking about Clippy. The older people in the room will remember that really, really annoying paperclip that Microsoft birthed back in the 90s that was supposed to be helpful, but actually was just maddeningly annoying and never really helped. It was the worst. So I can remember coming to Rust and everyone was talking about how great Clippy is. I was like, what? Later finding out, obviously, that it is actually a new and much, much better thing. But yeah, one of the really, really great features of using Rust. And an awful lot of organizations, when they are thinking about, okay, what should we build this new thing in? Should we build it in Rust? A lot of the kind of anxiety or reluctance to migrate to Rust is this kind of, am I going to be able to get the right people? Am I going to get, do I have to upskill or get my existing devs to learn a new language? Do any of you have any advice for organizations that are thinking, okay, no, we'd really like to build this in Rust, but we want to, we're going to need to get our devs to actually learn this new thing?
Yeah, I've got a few things to say about that. So I think there has to be a sort of a fundamental paradigm shift for companies. A lot of languages like Java and C#, there's generally you hire somebody who's already got commercial experience, whereas Rust, generally you're going to hire somebody who's got lots of open source projects behind their belt. It's a totally different thing. Companies are not comfortable with that, and I think if they want to hire developers, they need to change their minds about this sort of stuff, because there's only when something is new and starting out, there's a chicken and egg problem here, and saying, oh, we can't find Rust developers. That's because there are fewer Rust roles than these other languages. So a lot of the time, for me, case in point, it's much easier for me to find a C# role because I've got 20 years of experience in it. But I have the same skills in C# than I have in Rust. But people won't hire me for Rust because I have 6 months of commercial experience in Rust. So this is, yet that's got nothing, it doesn't bear any difference to, my abilities in the language. So I think that should be a sort of a big paradigm shift. What are your actual skills and what can you demonstrate rather than what is your commercial experience in the thing?
I do think the demand for Rust developers is increasing exponentially, though. I was at ARM last week, and someone there threw up a few statistics, and the demand that they've observed is that demand for Rust developers is up by 38% this year, and it's the only one that has gone up. So Rust it's slowly getting there. So thinking a bit about Rust as a kind of high-level language, as people would describe it, but with speed as well. Tim, maybe you can speak to this. Rust aims to give you C-like performance, but with a high-level feel, if anyone knows what we mean by that. But how does it balance? How does it balance being user-friendly while delivering the speed you need for systems or kind of cloud applications?
Yeah, sure. I've written down some buzzwords for this one.
Excellent.
We've already mentioned zero-cost abstractions, which is a key thing. So in this, for me, I look at a language and I get a feel for is this a high-level or a low-level language in terms of the way it reads and the code that you're writing. Is it down in the details of how the machine works, or is it up at the level of what are the problems we're solving here? And for me, intuitively, Rust is relatively high-level. It's definitely possible to build higher abstractions and reuse them. Certainly, I was a bit disappointed with Golang. I had quite high hopes. I liked the idea that it's this simple language like C where you can build complex things out of it, but I found it relatively repetitive and a bit limited in its ability to build these higher abstractions. That said, if you're coming from Haskell, you might be slightly disappointed with Rust. I have heard that one feature is missing is higher kinded types, which I had to go and look up, honestly. So we have quite a lot of the higher level abstractions. So you can have a function as a variable and pass it around. You can have your lambdas. You can have your, I never know the proper names for these, like the MapReduce kind of functions, your list comprehensions. You've got your generics, you've got your various, quite a flexible type system. There's an absolute ton in there. There's a bit of extra syntax in there for the borrow checker, which takes a bit of getting used to. I think I'm still getting used to it, but like we were saying earlier, it's there for a good reason. It buys you this zero runtime speed, but still maintaining that safety and high level. What else have I noted? And just one thing, which is not really about it being high level, but it's a sort of familiar C-like syntax, which for me, I've tried doing Lisp type things. It never ceases to confuse me. Honestly, I just don't think that way. So for me, having done C# and JavaScript and Java and things like that, it's familiar. The only other thing I'd mention on the kind of higher level, it's not strictly an object-oriented language. So if you're coming from Java or C#, you might be a little bit like, oh, where are my classes? But it has enough of the similar things. And having done Ruby, where they believe a bit more in composition versus inheritance, I've kind of bought into that already. They have traits which no one's allowed to say they're interfaces for reasons that I don't entirely understand. So hopefully that paints a picture. There is a lot of the high-level concepts in Rust, even though technically it's a low-level language. And I personally think that's utterly unique in programming languages. I don't think there's anything else out there that gives you both in one package. Yeah.
Oh, sorry. Do you want to? I'll go after you.
I just wanted to touch briefly on Tim talking about the lack of classes and Rust looking like a C-like language. It's sort of a functional language in disguise. It's a functional language disguised like C. So it's sort of a gateway drug, tricking people into learning more functional concepts when they least expect it.
From a embedded Rust point of view, I was I used to use Arduinos quite a lot, which is C++. And I don't know if you guys have ever looked at the Arduino ecosystem, but the programs are very straightforward, and it's a great ecosystem, and that's why it's so successful. But the minute you want to sort of make your own driver or do anything sort of technical, you get into the weeds, and things get really difficult. And I always wanted to write embedded software, and I wanted to write it in C#. And for a small period of time you could, but it wasn't very well supported, and you have all these runtime problems. And then Rust came along, and I could use these higher level concepts to make, you know, low level stuff, and that was an eye opener for me, just being able to not worry about things that I didn't really understand properly at the time anyway, because, you know, it just forced you down this path. Yeah.
Awesome. I mean, I'm hyper aware this is the memory safety panel, but of course Rust also offers an unsafe option, so we should probably kind of talk a little bit about that as well. You know, it's kind of an escape hatch for memory safety, so you can actually, you know, you're able to violate those memory safety guarantees. So can all of you maybe talk a little bit more about that? You know, what's the implications of using unsafe Rust? You know, and does it defeat the entire purpose of memory safety?
Okay, so unsafe Rust, for starters, most managed languages have a safety hatch that you can climb out of anyway. It's just very rare that you do. And as Rust gets more and more mature, people reach for unsafe Rust less and less. So some projects just never see it at all, and some projects they kind of have to. What unsafe Rust really is just breaking the borrowing rules. So it means that you can essentially reference any memory in your computer program you like. So it's called dereferencing a pointer. There are a couple of other things you can do, like if you want to interface with other systems and stuff like that are not known to be safe. Like you want to call, say you want to call a SQLite database function that is made in C. Even though SQLite has been tested to hell, you still have to use unsafe because you're calling it, you know, you're calling something that's outside of the Rust ecosystem. So that's kind of what it is. It's a scary thing, but there's this excellent book called the Rustonomicon, and if you really want to learn a little bit about what the implications of using unsafe Rust, then that's a good read. But yeah, it's essentially we're reaching for it less and less. For most of my projects, I don't use unsafe at all. I don't have to. That wasn't the case 2 years ago. I had to use it quite a lot. As certain things in Rust get stabilized, we need to reach for it less and less. So yeah.
Yeah, so this unsafety, this code that you need to trust to maintain its own safety guarantees, it has to live somewhere. Like if you have a garbage collector or some other type of managed language, you need to still guarantee that the code that people write is safe, and that's going to have to be by ensuring that the runtime, the garbage collector, upholds those guarantees. And the garbage collector is not magical; it's written with code. So Rust goes about that a little bit differently, because you have the Rust language itself maintaining memory safety using the ownership and borrowing system, but also a lot of Rust is in the libraries. Like Rust is has quite a large library surface area. A lot of things are implemented in code rather than implemented in the language itself, and the libraries have to play their part in ensuring that those safety guarantees are maintained. I don't do embedded like David does, so I've only had to use unsafe once, and that was for a side project. I've never had to use. There's no unsafe at TrueLayer, but it's about just trusting the core is verified to be safe. Like maybe it's just a few libraries. Like I know that the Rust Foundation and AWS have this initiative to verify the standard library. So that's using formal verification methods to prove that the Rust core library maintains the safety guarantees. So even though we have this escape hatch that every memory safe language has, in Rust we have a lot more scrutiny on those pieces of code that use that escape hatch, and we also have these higher standards that when you do break that escape hatch, the thing that you expose, it's impossible to then use that to violate memory safety, because we have these strict rules that if you have a function that is safe, if it uses unsafety inside that function, you must be able to show that there's no way of using this function to violate memory safety. So the memory safety stops there, and then everything above can then imply that everything above is therefore safe.
Brilliant. Thank you very much for that explanation. I realize we are running out of time, so I'm going to ask a final question, and maybe we'll have time for audience questions. But kind of forward-looking, as David kind of said, even just in the last 2 years, the way that Rust has developed is changing behavior, and it's changing possibilities in what you can do with the language. So where is Rust going? Where are we going to see it popping up? What's it going to be useful for in the future? In 1 year, 5 years, 10 years? I think you've probably all got quite different answers.
I've never talked enough. So part of my interest, my continued interest in Rust, is that it's this building wave. I keep being distracted by my C# clients, but I still have an ambition to build a Rust consultancy, and that's a bet on the ecosystem. It's really good to hear the stats that I'm not completely off the mark, that this is a growing area. I personally have a theory that as more and more teams build Rust internally, they have experiments, eventually they'll grow and they'll need to start doing commercial level quantities of Rust, because you've done that one niche little thing. There's a problem in an organization or a department when you have multiple languages. It's a real challenge. I was on a project where they had C#, Node.js, and Ruby on Rails all within the same department, which was great fun. So after a little while, there was a perfectly reasonable decision to rewrite it, in this case to Ruby on Rails, which I won't go into that because that's not the point of this. The point is that there is a significant cost to having multiple languages, and because Rust has some very unusual properties that makes it head and shoulders above some of the offerings in certain niche cases, once you've got that in, one of the things I'm hopeful for, and I think is really coming home with Rust, and is probably timely for me getting into it, because I tend to do more like API, web, line of business things, the ability of Rust to move into all areas of programming is really quite remarkable. We have our embedded expert here. Like, I do like microservices things. I could theoretically use it for that, and I hope to. You've got WebAssembly, you've got WASI, you can do serverless with it, you can do phone apps, you can, like, there's not really an area that this can't touch. You can run it in the browser. So there's definitely something to be said for the fact, like, well, if you've got a team of 10 people, why don't we just write everything in Rust? So I really do think that there's a big future. And there's just a couple of quick things I want to say on it, which is cost is not a small thing. Like, the hosting costs of running Rust are significantly less just because it's such an efficient language. Like, nothing really comes close. Even Golang can't quite meet it. And in terms of talent, like, I've been around this industry for many, many years. Like, I got really enthusiastic about Ruby on Rails for quite some time. I joined the community. And what I've noticed is that the best developers are always looking for the next thing that's going to solve all the problems, the next holy grail, the next language that's everything. So if you're a hiring manager and you want to get the best people, like, do you want to be having them write COBOL, or do you want them writing Rust? Like, which people are you going to get? Are you going to get the forward-thinking ones, the ones who are like really pushing, or are you going to get what I see in a lot of enterprise C# projects where like there's people who just don't really give a damn. Like, you pay them, they'll show up and they'll write you some bad code. Like, there's a, don't get me wrong, they're not all bad, but there is a large volume of that. So if you're trying to hire great people, being on the leading edge of languages, there's a lot to be said for that.
Okay, fighting talk from Tim.
Yeah, building a little bit on what Tim said about using it for everything practically. I think we've touched on a few of those advantages of Rust that make it maybe a fit for that, like having this low-level control in the same language where you get this high-level interface. And one of the things that I've noticed has been really, really fun with Rust, working on high-level projects, working on payment systems, microservices, is the ability to jump to definition on functions and always stay in Rust. Like, I can go all the way into the TCP stuff or whatever, like crypto stuff, and it'll always be Rust all the way down. And if I was writing in a managed language, maybe that would be an FFI boundary that goes to C or another language. I'd have to break out of my Rust thinking, and that's really cool if you've got a big project where maybe you've got some performance critical things and some high level things in the same project. You could write the whole thing in Rust, but also cool for open source contributions, because all of your libraries that you're using are in a language that you know. So if you need to debug them, you need to work out what's wrong, you have the skills already to go do that.
And what I'd like to see in the future for Rust is easier onboarding, so just flattening out the learning curve, so that, and that's, smarter tools like Rust Analyzer helping you a little bit more. The compiler messages are already great. I'd also like to see sort of less churn in, the compiler itself is very stable now. It doesn't change much, but libraries are still being written and they're changing a lot. So this is one of those things that it's quite exhausting, because things are changing so much. I think as the future goes, certain things will be, this is the way we do. Already, like if you're using JSON serialization, there's only one crate you use for that. That's a thing now. That's a solved problem. I think we'll see more and more of that, and that's what I'm excited about with Rust, and it just needs to get easier. Yeah.
Thanks, David. Yep, Tim, final word?
Yeah, I'm trying to get the last word in. There was a couple of other things I thought while you were talking. And also because there's a bit of a focus on policy here. So you mentioned developer experience, and that's definitely a thing. And training as well. I was listening to Tim McNamara, who's training Rust people, which is great. That's, from my understanding, in terms of the building of the ecosystem, enterprises want to know that if they hire 10 people, they can get the commercial training. So that's a really important part that he's providing. And on the policy side, like if you're in control of like the high level and pushing things, like there's definitely some things where you can push towards Rust without necessarily saying Rust. So I gather, I don't know which government department it was, but one of the United States government departments declared that they were not going to have any memory unsafe languages.
White House report.
White House report. I don't know. I'll just shout.
You're fine.
And as a result, C and C++ are just not a thing. And there's a big move into Rust. But it's not like we should use Rust, rah, rah. It's just like, here's a problem, let's solve it. Policy level, this is what needs to change. And you can do the same. Like, the green movement is massive right now. Like, a big part of the CO2 and energy costs is server farms and just moving to a much more efficient language. Like, we are so inefficient with our resources. Like, the towers of abstractions that we have in programming are just unreal, and they're not getting any smaller. So moving something more efficient is interesting to me, but also arguably an ecologically good thing to do.
Thank you. So next year's panel, Tim, will be on Rust in AI and how we're bringing down the costs. Thank you so much, all of you. We've probably got time for one or two questions if they are quick, if anyone has them. Can't see everyone.
I hate being first. Thank you for kind of expressing your perspectives and thoughts around your experiences with Rust. You've talked a little bit about onboarding, developer experience, the beauty that there is only one package manager. However, that's not the case. There are other package managers that are being developed now because they're or compilers that are faster. We want something faster. We've seen this in almost every language. Are we going to see over time? Rust is young, right? Are we going to see over the next 3-4 years newer tools that are going to compete with the existing incumbents as they become bigger and ossified and don't want to break backwards compatibility? So they say, no, we're not going to take your optimization, so somebody else is going to go build another tool that does that. Are you at all concerned of that kind of future? Because we've seen it happen in every ecosystem in the past. I see no reason it won't happen in the future.
Yeah, I mean, that's definitely something that concerns me. I having, like I say, moved around lots of ecosystems. Like in the Microsoft world, it was historically much more Microsoft gives you the one answer. It's a bit naff, but that's what you use. Whereas in the other ecosystems, there is a lot more cut and thrust. It is the cathedral and the bazaar. It's like, do you have innovation and lots of alternatives? But then you have to have a really hard think about which one you're going to use. Like Ruby on Rails has the same thing with Sinatra versus Rails. And what I found there was that for the team of mixed developers, Rails is great because it's the one answer. It chooses your ORM, it chooses your routing, it chooses your mapping. But the senior developers who've done Rails for 10 years are like, this is very limiting. It's not the best of breed. I want to use Sinatra and I want to pull in all of these different pieces. So for me personally, looking at the Rust ecosystem as it stands now, like without trying to predict the future, I like the balance it has. Like the web frameworks thing, I think, is a bit puzzling for me, and I'm hoping that one settles down a bit. I'm currently reading a book, Zero to Production, which has one of the frameworks, but I'm probably going to use a different one. So, but maybe that's going to be part of my job with the consultancy. It's just like, what's the current best opinion, just to save somebody else the hassle. So it's a very valid question, and I think we'll just have to see. But it looks positive to me, in my view.
I like that we've set really high standard. So if we do get additional compilers or additional build tools, they will have to be as good as what we've got now. So at least we have that going for us. We're not going to get something that's really, really horrible to use. Currently, with sort of alternative compilers, there's sort of maybe a bit of a pushback towards having more compilers. There's the GCCRS project that has an alternative compiler front end and back end. But a lot of the focus has been, as I understand it right now, is more towards having alternative compiler backends that make use of the same compiler front end, which would be a lot less disruptive for the ecosystem.
Great. Okay, well, I am hyper aware that we are standing between you and lunch. So I'm sure any of our panelists will be more than happy to ask any other questions that you have. But I just want to say thank you all very much. I think it's been really, really useful and really interesting. So thank you.
Thank you.